So hi, I'm Matt Turner. I work at Tetrate. Just very quickly, I'm here because we make a management plane that sits on top of your Istio service meshes. We can install Istio for you, configure it, set up multi-mesh, set up hierarchical permissions, give you an abstraction layer over complicated Istio config, all kinds of stuff. So if you're a sophisticated service mesh user, then I guess come talk to me. If you're not, it's not going to make too much sense. But I don't want to, I think it solves a real problem, but you've got to be in that mine, you've got to be in that trench to have that problem. I'm actually not going to talk about that. There will be some Istio. I can't keep away from it. I don't really want to talk about that today. I want to talk about, oh, we're not on the, is this not the presenter view? My production values, man. I think this is the presenter view. Oh, well. But hopefully it talks better than the slides. I want to talk about AppOps, which is a term that I've kind of sort of come up with to talk about some thoughts I've been having, some ideas I've been having around the way we organize teams and the way that we allocate work and the way that we do things and the tooling that we build to do that. I kind of want to honestly put this out there, explain this idea, see what everybody thinks, get some questions, get some feedback. I also have no idea how long this is going to take, so I'll try and do about 20 minutes. So has anybody ever had a corporate laptop? Like a big chonking thing like this? I couldn't get one with a VGA port, but you get the idea. And if you ever tried to install software on it, right? Something innocent, Spotify, uTorrent, Spotify, right? And you get this kind of error. You can't. You don't have permission because this is provided by the corporation, by the enterprise. So this thing doesn't let you do some of the things that you want to do on this laptop. Now that laptop was given to you by IT. In the beginning there was, IT. They bought these machines, they ran cables, they sorted out the power, they installed OSs. And over time they added firewalls and load balancers, virtualization, and consolidated where we had separate storage, right? We had SANs, and then we consolidated again, and then we went hyperscaler, vertical, or whatever. They did all kinds of stuff, and this got really complicated. And as this infrastructure became more and more complicated, it became kind of more and more unwieldy, and they ended up doing everything. They had to deploy our apps, the apps running on that infrastructure, because it was nuanced, it was multi-step, there are a lot of minefields. So they would end up doing, this is drag and drop into IIS, right? This is kind of deliberately awful. But they would end up doing this kind of stuff with IIS or with jars or with wars or with whatever. Now the IT team's job was to keep availability high, to keep security high. And they did that in the obvious way, the easy way, which was to not change anything, right? To not want to do those deploys. They had become very, very good at ops, to safely and predictably performing maintenance on a schedule, performing upgrades on a schedule, performing patches on a schedule. But this approach doesn't really line up with the devs team's desire to move fastly, wow, bigly words, to deploy fixes fast, to test hypotheses often, to be agile and all of those cool buzzwords. So this is, I can't come up with jokes this good. But IT sysadmin would have incentives kind of like this, and there was seldom communication, often from the IT basement up to management, and between IT and the sort of teams developing the apps that they were deploying. Things would just come over the wall, and there wasn't a lot of communication. There was quite often some sort of resentment. So given some very straw man sort of systems diagram, architecture, tech stack, you have infrastructure that might look a little bit like this, right? You've got your hardware at the bottom. This is the racking and the stacking, and if anybody's ever done data center work, right? You've got your hard hat and your ear defenders and your radon suppression system and stuff. And then we maybe had a hypervisor, we had OSs in that, we had apps, and there's a whole load of complexity and nuance to this, obviously, but it looks a little bit like that. And IT kind of started off here with the hardware. No offense, by the way, to anybody who's ever called themselves IT or been a sysadmin. It's a really hard job, and it's got a lot of conflicting requirements on it. But I guess this is maybe where the skills and the processes started, and it ended up doing this, right? They ended up. Anybody who's ever done IT, you're like, or even DevOps, right? I've been infrastructure at a startup, and suddenly the website's my problem. I came there to do Kubernetes, like cool advanced Kubernetes stuff. The website's my problem. The email's my problem, right? And I'm sure we've all seen that. And this is the same kind of pattern. They ended up coming up this stack and kind of doing it all. I think the combination of this was Google's SRE model. So these site reliability engineers, as they're called, they have complete dominion over this production environment, right? Over the whole tech stack in production, over the deployments of apps into that environment, into the operation of those apps. Now they're super highly skilled people, right? Both as traditional sort of operations engineers and as software engineers. And they developed a whole load of tooling and automation to perform those operations very, very efficiently. So here I've added just one layer into this stack that says cluster. Now in Google, that would be Borg, which was really no mean feat of software engineering. But SRE added Borg, added the cluster to their stack for their own advantage, right? It made them more efficient. It was automation. It reduced the bottom line. It made them faster. It made things cost less because it solved their problem. And it's very tied to Google's other technology. It's very tied to Google's ways of working. And that's why it wasn't open source. That's why Kubernetes was kind of re-implemented, right? Because you can't open source Borg. You just couldn't extricate it from all of the Google stuff. So SRE owned the power and the cables and whatever. Remember when Facebook fell off the internet? Because again, like super hard job, no offense to anyone, but like their SRE have to deal with everything. And they accidentally yanked all the BGP adverts one day, right? And Facebook just fell off the internet. So everything from the low level right up to and including, in Google's case, they own the apps as well. So this is, SRE, color the whole thing in. What about our poor app developers and their apps? Well, this communications issue, this wall that we maybe had before, was addressed by formalizing the communication. So any app that wants to run has to come with detailed instructions, in a specific format. It has to come with playbooks and runbooks. And to kind of avoid the ops team's common complaints about having to pick up the pieces after a bad deploy, after a bad version, SRE were empowered to choose what they adopted, right? What could actually run in production and to refuse to run things that didn't meet their quality bar for software quality or for documentation or whatever else. So there's still a wall, but it's kind of very explicit, it's very well documented. And the contract of that wall is the devs know that their software won't clear it unless they tick all the boxes of making sure that things scales properly, making sure it's highly available, making sure they have all the documentation in the right formats. The flip side of that is that SRE are obliged to catch it and run it on the other side if it does. And obviously this works very well for Google, right? It works to this day, but it's kind of predicated on the ability to hire lots of really good developers into this role, and it's predicated on taking years to build all of these ways of working and all of this tooling. And it also has, I think crucially, a sort of executive level support for SRE. As a function as a way of doing things. And this is super important because that top level executive buying for the dollar cost of the salaries of all these highly talented software engineers, right, they're not delivering features, they're doing something else. The time it takes for them to learn all the apps and build all the tooling, and their ability to stop the line and say, I don't care how important that product is, they're not shipping any new features until they've got their quality bar back in the right place. And SRE is totally empowered to do that, and they have like highest level executive backing to do it, which I think is maybe why no matter what job title you give people in your organization, you probably can't do SRE. I think that's a very unique position to be in. But I wanted to mention it because it's, obviously works very well for a big, sophisticated, profit-making company. The SRE workbook is still an amazing, there's all kinds of information in there on monitoring and high availability and all kinds of stuff. It's still a very worthwhile read. So this brings us to DevOps, right? I think most companies sort of frustrated with that IT department approach, but either unwilling or probably unable to adopt SRE, kind of swung entirely the other way. But they did this DevOps thing. I'm not going to do the thing where everybody clearly wants pizza, I think. I'm not going to do the thing where I ask everybody to give their definition of DevOps, right? Because we'll get n+1, we'll get a different answer from everybody except for one person who's like, oh, is it this or is it that? And they give 2. But hopefully we can agree on like a few areas. So for this stack, well, the first thing DevOps talks about is what we do. So it's about automation and observability and rapid feedback, right? So we look at the sort of so-called DevOps tools, everything from Kubernetes and Terraform through to Incident IO and whatever. And this is maybe what you test DevOps people on in an interview. And don't get me wrong, like Kubernetes, Terraform, especially Docker, these are amazing tools. They've enabled this DevOps revolution. They've, in a lot of ways, driven it, especially Docker being there and being such a great tool. But yeah, the first thing we can do is take that sort of automation APIs thing to heart, and we can just get rid of a couple of layers off the bottom of our stack because I don't want to do physical security, right? I don't want to have to listen for the radon klaxon all the time. It's kind of paranoia. So we can get rid of a couple of layers down there. And DevOps sort of talks about how we do things. We want to be lean. We want to be agile. We want to do the plan, do, check, act loop. Whatever is the flavor du jour of moving fast and breaking things. It's all about being quicker than having to wait for IT to do deploys on Saturdays. Now, app devs are used to this. This is kind of how they want to work. It suits them. So the app dev team comes in and they run their app. And it kind of talks about who does it. So DevOps is, I think, usually understood to mean a cross-functional team, right? So who own the whole lifestyle of an application and who own the whole tech stack, this you build it, you run it thing, including the infrastructure. So you've got an app team doing ops, and we've got a couple of layers off the bottom for them, but they're still going down a few layers. So they're going to deploy their app to the cluster. They're going to make the cloud load balancer for their app, and they're going to set the firewall rules on that. And you hope they get them right. And they're going to make the cloud database that their app needs, and they're going to manage those backups, right? Definitely going to manage backups for it. Mm-hmm. So the idea is that I think if you have people with infrastructure skills in your organization, then you spread them out between the app teams and you make these cross-functional teams. And they do the infrastructure work that the teams need. But I just think the team is cross-functional, right? The engineers aren't. I won't get into the whole, whether I believe in full stack developers or whether I believe in T-shaped developers or whatever, but I think you have to step a long way back to say, oh, that's a cross-functional team. You maybe, if you're a Python dev, you probably still have to talk to the person next to you to get some infrastructure work done, right? To get that cloud database that you need. Now, sure, at least they're sitting next to you, they're in the same meetings, but it's only maybe cross-functional from a distance. And you combine that with the short planning horizons that maybe come with something like Agile, and you can get a bit of short-termism, you can get a bit of overfitting. And I think you also lack the cohesion between the infrastructure people, because now you've taken them and you've spread them out to make these cross-functional teams. The infrastructure people are not sat next to each other, right? They may be in some Spotify-scaled Agile like guild, but in my experience, it's kind of not the same. And by Conway's law, if you've got 10 teams working on platform, you're probably going to get 10 platforms, right? And of course, you may not even have those infrastructure people. Like if you try to hire an infrastructure person yesterday, everybody here obviously is probably an infrastructure person who's laughing into their massive salary, but it's a hot market, right? Like not everybody can get them. And the cross-functional thing can bite you as well. I've seen agile transformations too that I can think of, where all the testers were made redundant because, the team's cross-functional now. But the devs can just do it. It's only testing. And I've certainly seen the you build it, you run it thing weaponized to avoid hiring infrastructure people for as long as possible. It's saying, oh yeah, the devs can do it. So you're giving this infrastructure work to people who aren't skilled in it, who aren't necessarily motivated to do it. And even if they can, it's hard. It takes time, right? There's an opportunity cost to them doing that. And this isn't front end. This is important. I'm kind of joking, half joking, but infrastructure is critical for security, for data privacy, for data durability. It's a job that needs doing and needs doing right. So does front end. Otherwise, you don't have a product. Don't get me wrong, or everybody hates it. But infrastructure also needs doing right. And you get, I think I won't labour the point too much, but I think you get all of these maybe bad side effects when you've got this sort of Conway's law, all of these teams doing the infrastructure themselves, this, what am I trying to show here? I can't remember, this was a joke, but I'm too far into the slides to remember it. I think maybe these people are on Heroku, they've just given everything away and they're happy on Cloud9 just running their own thing. They got this wonderful infrastructure beneath them, but they are 90% of the cost of the whole business. These people are on ECS. It's like a cluster, but a different flavor that doesn't run very well. Or it's app run, and nobody can actually really tell the difference. These people just decide to do it themselves. So they're out there doing sort of, they came on-prem and they're out there doing ESXi upgrades. So it's not necessarily great. So this is the provocative title that I think I put in the trailer. You've got to get everybody's attention. I'm not here to sort of slag off DevOps. Even the term is a complex and nuanced thing. What it means to people and what people are doing is very context dependent. But what can we maybe do? Can we maybe do a little better? So given our stack, okay, pay for what makes sense to pay for. See your Wardley map, see what makes sense for your sort of economics. Get the app devs in, running their stuff in prod, understanding their app technically and how to restart it if it gets in a bad state in the middle of the night, and understand its commercial context, its customers. Like, how quickly do we want to get new features out? Where does the quality need to be? Is this a beta page on the website? How much risk can we take with it? I think that kind of, it has to be run by the app team or people associated with them, because they will understand that. And then we get a platform team, right? A dedicated team with infrastructure skills, providing a common platform for everybody. The platform engineering is sort of becoming a thing. A platform engineering, as in the hashtag, the name is becoming a thing. You see it on Twitter quite a lot at the moment. It's kind of gaining momentum. And I think it's good. I'm in favor of it. It reduces complexity and cost across the business. It lets devs move between teams without retooling, et cetera, et cetera. We all know the advantages probably. But some variation of this is probably what we've all been doing for years, isn't it? I mean, it's kind of common sense. The platform team might have been called IT or might have been called DevOps or infrastructure or something, but it probably looks the same. But I think with platform engineering, we're now being explicit about it. We're giving it a name. It's a team and a function that we sort of celebrate and we invest in. They're not hopefully seen as just a cost center where their job is just to make things more efficient and reduce, costs. They're seen as something that can add value. I'll talk about Istio, right? You take a service mesh, you don't have to write all that retry and back off logic in your applications because you can just configure the service mesh to do it for you. So it can add value to people maybe. So we encourage them to go and use cutting edge tech. They have still a responsibility like IT did for uptime and compliance, but they also have a customer, the developers of these apps, and they have a responsibility to them to deliver useful features at a good pace. I maybe painted a fairly extreme picture of IT with them doing sort of everything, but I've been there. Sort of 10, 15 years ago, I produced a jar, it was a .NET thing, put it in a share folder. IT would deploy it at the weekend. If you were lucky, they'd do them one server at a time, unless there was F1 on in the afternoon, in which case they'd do them all at once, and then you better hope your code was good. And it's the same with DevOps, am I really saying, Node.js devs are doing everything? Well, it might sound crazy, but that probably describes every startup like I've been in. So there you go. So I think this is better. But I don't think it's quite the end game. We still have this wall. We still have this line here. And as I say, we're being explicit about maybe the contract between them. We're being explicit about the roles of each team, and we're kind of investing in both. But it still looks a little bit more like that corporate laptop of mine. I can do anything as an app dev. I can do anything I want, as long as it doesn't need admin. So what do we do? Do we sort of blend it together? Do both teams have permission to sort of fiddle with both things? Can the cluster ops people reconfigure the app at the weekend if there's an outage? Can the app people go and fiddle with the infrastructure? So I come along and I open a port to serve my new application, and then platform closes it because they think it's a security risk. But they're on a different floor, so I don't wander over and talk to them. I just bitch about them, and then everything falls apart. So I want to introduce this thing that I'm calling AppOps, slightly by saying that this kind of shared responsibility is no responsibility. And I think what we need is clear, explicit responsibilities for both teams, and sufficient but minimal permissions to meet them. I think we need to acknowledge that Kubernetes, and this is especially Kubernetes, this is why it's such a win, is a platform for building platforms, right? So it takes people here with specific skills to build a platform appropriate for your organization that you need. And they'll have built some of that platform to serve the app devs, sure, but they'll also have built some of that for themselves, for their backup and for their recoverability and for their auto-scaling and monitoring and all that kind of stuff. And I think the other thing is that an app doesn't just exist at that top layer. It's not just its code. So a well-functioning, well-performing app is the code that you've written, but it's also a fast cloud database. It's also 3 volumes with snapshotting turned on. It's running on a cloud instance with 10 gig networking because it needs that. So your organization's people and their responsibility and their authority form these complicated patterns, and they don't neatly map onto a one-dimensional diagram like this. I think that's maybe what I'm trying to say. If everything's Pulumi, then should an app dev have to raise a ticket to get any piece of Pulumi run just to spin up a new cloud database? No, I'd say not. But can everybody run all the Pulumi? Can the app devs go and fiddle with the settings of the Kubernetes cluster? No, I wouldn't say that either. So I think anywhere in this stack, as far down as necessary, I can't really think of an example where it'd be here, but as far down as necessary, where there's a legitimately diverging requirements between 2 apps. So 2 apps have got legitimately different requirements. They should be able to go down and alter them. They should be able to self-serve. But I think self-serve is a lot more than saying, oh, well, we built a platform and you can come and meet our explicit boundary, and you can come and run as long as you only want to do these things, as long as you don't need root, as long as you're happy to fill in these particular fields in the Kubernetes, in the Helm values.yaml file and nothing else. So this is my corporate laptop where IT can come all the way up maybe into my and configure part of my Outlook to enforce an email signature. But they're not going to completely lock the machine down and stop me setting the desktop wallpaper. It's where I can take that laptop and I can go all the way down into the BIOS and I can change the touchpad exclusion settings or something, but I can't disable the antivirus. This is where G Suite in your Gmail corporate Gmail settings, you go in and it says, this part is controlled by the domain admin and this part isn't. So just to take a quick example I had to put some Istio in there. To take a really quick example, this is ingress into a Kubernetes cluster, right? Port 443 is open, request comes in, this one's going to go to B, not A, it's service B, not service A. I use Istio as an example because it's got a really nice API for this that separates those concerns. So gateway says, the gateway resource, CRD, says what port to open to the outside world. Virtual service says, look at the path, oh, it's /orders, send it to service B. Authorization policy says whether the particular user that's logged in, their requests are allowed to get to B. And then destination rules says, okay, we're talking to B, how do we do that? Is it idempotent? Can I retry these requests? Do I need to only try them once? But your platform team might want control of the gateways, right? Which ports to open is going to depend on how the upstream networking is configured. The architect might want to write the virtual service because she's the one who knows, which path, whether /orders has been migrated from the old monolith into this, into the strangler pattern, into this new microservice B yet. Security are probably going to want to be the only people who are allowed to fiddle with those authorization policies because they're an RBAC thing. And hey, maybe we can let the intern on the app team play with this destination rule because she's implementing the code and she gets to fiddle with the timeouts and retries settings until her code kind of appears stable, right? So this all exists at the same layer in that stack. This is all Istio config, but we've got 3 or 4 different teams here doing things. Some of them are coming sort of down from on top, if you want, and deferring things to the infrastructure. Some of them are coming up from the bottom and are using sort of high-level infrastructure with abstractions. And more than that, like infrastructure, the infrastructure team is obviously going to build this and give other people, delegate certain permissions to other people. They probably can't keep up with all the joiners, movers, and leavers in a big organization. So they're going to want to give virtual service and destination rule permissions to, say, the team's manager, who can then go and delegate them onwards as people cycle in and out of the team. So this AppOps boundary that I'm talking about, I think it needs to be crinkly. I think that's probably the main takeaway. Like, stop either looking at a nice oversimplified diagram and saying this layer is this person's and this layer is this person's, because then I just don't have admin on my laptop. And I can't turn off the AV, but I also can't change the desktop wallpaper, which is a totally legitimate thing I want to do. And I think stop trying to build abstractions to like paper in the cracks. Stop trying to build abstractions to make it into a straight line, because that shouldn't be driving the requirements for those abstractions. I think that boundary needs to be sharp, like it doesn't need to be that fuzzy gradient. It needs to be very clear what everybody's responsibility is. Everything should have one responsible person. Shared ownership is no ownership. And it needs to be very clear, what dev and platform and security are doing. And it also needs to be documented. It needs to be understandable so that security and compliance can sign off what on earth you've built here, right? Because this kind of diagram, it's very simple to show security and compliance. This, less so, but I think it's the right way to do it, and people need to understand it. So you're going to have to build some tooling to do this. Like everything, in DevOps in the modern world, it's all about APIs and automation and tooling. I think this needs a few attributes. It needs those permissions. They need to be hierarchical, like a business unit, and then a team, and then a whatever. And they need to be delegatable so that they can be passed on. This is how you manage, because your organization is going to be complicated. And this is how you manage that organizational scale, that organizational complexity. Is like one central person in security or in infrastructure can't really do that. You need to have bounded parcels of it need to be handed down. The changes need to be visible, because we do have both teams interacting. Although there's a clean line between them, they're very close. And every time something breaks, each team's going to point at the other team, right? They always have, and they're closer now than they've ever been. So if somebody makes changes to my stuff, if I'm the app developer, or infrastructure comes along and changes a little bit of my config, even if I don't have permission to write to that, I need to be able to read it and see what they've done and reason about it. It also needs to be multi-tenancy, I think, if this is going to scale in any way. So while the platform team has responsibility for the whole company, as an app dev, I can alter all the settings related to my app, but I can't even necessarily, and I can read down to see what infrastructure is set up for me, but I can't even see side to side. And my organization might not want me to even know what other apps are running in the cluster. And it needs to be auditable. I think a lot of the tools we build this out of have some kind of audit functionality. Not all of them do. And again, security and compliance, if you're talking about something that's complex, they're never going to sign it off unless it's kind of ticking those kind of boxes for them.